Okay, so now we're getting into what I consider to be the most challenging part of factoring, and that is factoring trinomials with a lead coefficient other than one. They're not brutally hard. They are without this technique I'm about to show you, but with this technique, they're really not too difficult. You just got to be careful not to forget to do something at the end. It's especially not difficult with a graphing calculator to aid you. Now, the quick mental check becomes real important with this. So this is the hard part. But before we actually begin this, I just want to mention that the next lesson we do will be very similar to the lesson we're doing now. This is lesson 14. Lesson 15 will be very similar to lesson 14. And then we're looking at taking a test. Okay? So I don't think we're going to do a lesson 15 will be a pretest coupled with a slightly shorter version of this particular work, and then we'll take a test. So this is not the only crack you're going to get at factoring. You're going to get another whole, more than a half a day devoted to that factoring. Okay, so without any further ado, let's get going on factoring some trinomials with a lead coefficient other than 1. So what do I mean by a lead coefficient other than 1? The leading coefficient is this number that begins in front of the x squared term. Now, every single problem that we've done so far was always x squared, which means 1x squared. All of a sudden, I'm going to put up a 2x squared, a 3x squared, and a 5, excuse me, x or n squared. And this makes things, yes, it's a little bit harder, but it's not harder overall. It's just that you need to do a little bit more work to arrive at the correct solution. The way I used to teach this going back about 20 years ago, it was harder, and only the people with really good heads for numbers, great multiplication facts, and able to add and go in multiple directions at a time with their head were able to factor these. But there's a technique I learned about 20 years ago for teaching this that really makes it a whole lot easier. So I suggest that we follow that, and I think that you'll get it correct. Okay? I'm sure you've seen these before. So let me do the first one with you, showing you the steps step by step, and then I'll go through and give you the opportunity to do some stop and starts. So in trying to figure out 2x squared minus 5x plus 2 and how to factor that, the first thing I do is I look for a common factor, and there is none. So when there is none, I'm going to, it says multiply L by LC. It means multiply the last by the leading coefficient, okay? So what I'm going to do is take the 2 in front, whatever number it has in front, I'm going to multiply it by the number at the end, and that's going to give me x squared minus 5x plus 4. Have I done anything hard yet? No. I just have to remember, when there's a number in front of the x squared, one of the things that I can do, there's another one we'll get to a little later, is just take that number in front and multiply it by the number at the end. And that gives me x squared minus 5x plus 4. Excuse me. Now factor that. That gives me x minus 1 times x minus 4. Now I'm not going to go over the factoring that gets you here. That you should know from the previous videos and the work that we did. Basically, I need two numbers that multiply out to positive 4 and add up to negative 5. And those are the two, negative 1 and negative 4. Of course, you could do this on your graphing calculator. It's no big deal. But at this point in time, if I were a student in my own class, I would fire my hand up there and I would say, oh, wait a minute, teach, this is great. So you're going to give me this really, really hard question with this number in front of this leading coefficient other than 1, and I get to change the question to something I already know how to do? Oh, I love this stuff, because can we do this like all the time, that if I don't know how to do it and it's really hard, that I just get to switch the question and I get to do an easier question so I can get it right on the test? Is it possible to do that? And of course, it's not quite that simple, okay? See, what we just did was we took this number at the end and we multiplied it by a number. So we changed its value. Now, because I multiplied, I have to balance or return the equation to a form that will give you the answer, and I do that by dividing, okay? So if I have to multiply by the 2 now. I need to divide by the 2 going back in. What do I divide by the 2? Just like it was the last term up here, I divide the last terms in the binomials by 2. So 1 over 2 becomes 1/2, and 4 over 2 becomes 4/2. Now I look at the answers that I have before me, these two binomials, and if reducible, I do that. So I get x minus 1/2 and then x minus 2. Okay? But we can't leave a factor in this form with a fraction in it. So do you remember how when you're in elementary school, if you got like, say, I don't know, 1 2/3, and it said converted to an improper fraction, you would do the 3 times the 1? Well, that's kind of what you're going to do right here. What you're going to do is you're going to multiply this 2 by the x. And that gives me 2x minus 1 times x minus 2. And that's the answer. So when I get the fraction that cannot be reduced, I simply take the denominator and I multiply it up here like I did in elementary school when I converted mixed numbers to improper fractions and vice versa. Okay? And then if I can reduce it, like the 4 over 2, I just do reduce it. Now, let's do a quick mental check and show that this works, okay? 2x times x is 2x squared. 2x times negative 2 is negative 4x. Negative 1 times x is negative 1x. Negative 4x and negative 1x adds up to that negative 5x in the original question in the middle, and negative 1 times negative 2 is positive 2. So the reason this works is when you realize it doesn't have a greatest common factor, you multiply, L stands for last one, and LC stands for leading coefficient. So you multiply the last term by the leading coefficient. That was 2 times 2. And then you just do your work as normal. But then you have to go back and balance out that multiplication with division. And you just divide the last terms. Since you multiplied the last term, now you're going to divide the last term. Divide it by whatever you multiplied by. So in this problem, you multiplied by 2. So therefore, you're going to divide by 2. Then you look at what you're left with. If you can reduce the fraction, like 4 over 2, reduce it. If you can't, then take that denominator, like in elementary school, and multiply it in the front, 2x minus 1. And then just check back to make sure you didn't make a mistake, like I did on a previous video. Okay. Let's have you try number 9. Don't worry about it if you don't get it right. Just try to muddle your way through it, okay? Let's do some stop and start. I'll go over it with you in just a minute. Okay, so first, since there's no common factor here, right? Nothing divides into all 3 terms. I'm going to multiply the last by the leading coefficient, which means I'm going to multiply it by the 3 in front there. And that gives me x squared minus x minus 6. Okay? So when I multiply that by 3, this leading coefficient is no longer part of the problem. So I just drop it. And it's x squared minus x minus 6. Then I just factor it the way I did in the previous lesson or video. And I get x minus 3 times x plus 2. And that works, right? Because negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. That's the AM technique. You could have done it on a graphing calculator. But now you have to balance it out. So you have to balance out that multiplication with division, which I do. And I do that by dividing back in, not by 2 this time, but by 3, because this time the leading coefficient is 3. So I get x minus, see, here's the term right here, it's 3. So it's 3 over 3. And here's 2, so it is 2 over 3. Now this first one's reducible, so it's just x minus 1. What do I do with this last one? I multiply like elementary school. I put that 3 in front, and I get x minus 1 times 3x plus 2. Let's check back. X times 3x is 3x squared. X times 2 is 2x. Negative 1 times 3x is negative 3x. Negative 3x plus 2x is negative 1x. And if we go up to the original equation in black here, that's what we wanted. And negative 1 times 2 is negative 2. Also what we wanted. Okay? Okay, try number 10 with a stop and start. Let's see how you do. All right, so I look for the least common denominator. I do not find it. So that means I'm going to multiply the last by the leading coefficient. In this case, the last is negative 6, and I'm going to multiply that by the leading coefficient of 5 and then drop it. So I get x squared minus 7x, that stays the same there, And then negative 6 times 5 is negative 30. Now I just factor that like I already know how to do from the other procedure. That's x minus 10 times x plus 3. Quick mental check, make sure it works. X times x is x squared, x times 3 is 3x's, negative 10 times x is negative 10x's, 3x's and negative 10x's add up to negative 7x, and then negative 10 times 3 is negative 30. Okay, then I'm going to go back in and I am now going to balance that multiplication with division. Since I multiplied here to start it, in order to get back to the original problem, I've got to divide. And I multiplied the last term, so I'm going to divide the last term. Okay, remember I multiplied the negative 6 by the 5. Now I'm going to take the two last terms, which are negative 10 and 3. I'm going to divide those by 5. Now, 10 over 5 reduces to x minus 2. But I still have this fraction here, and except in exceedingly rare circumstances, we never use a fraction. And if you multiplied this back, it would not check as it stands. But we know what we need to do. We need to put the 5 up here like we would have done in elementary school. So it's x minus 2 times 5x plus 3. Then check back. X times 5x is 5x squared. X times 3 is 3x's. Negative 2 times 5x is negative 10x's. Negative 10x's and 3x's do indeed add up to that negative 7x I'm looking for. And negative 2 times 3 is negative 6. So ding, 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 ding. I got it right. Okay? If you want, take a screenshot or take a picture with your phone of what you see in front of you here, because I was hoping you would notice that the process is exactly the same for every single question. And then you can use that to help you when you get other problems like this. Okay? All right. Now, I've been ignoring something that I should always do first because I wanted to teach you the hardest way to do this first. In actuality, what you should always do is look for a greatest common factor, like in the very beginning of today's lesson when we went over how to factor with the greatest common factor. See, I take a look at number 11 and every term shares a 2. And these are actually much easier than the 3 preceding questions that I just did. So, since every term shares a 2, what I should really do first is not just multiply the last by the least leading coefficient. I should always check and see, is there a greatest common factor? And there is. In this case, it's a 2. So since there's a 2, I'm going to factor out the 2, which is x squared, plus, once I factor it out, right? If I factor out a 2 from 2n squared or x squared or whatever, it leaves an x squared, because factoring is division. 10 divided by 2 is 5, and 8 divided by 2 is 4. You could check yourself by multiplying back, right? 2 times x squared is 2x squared, 2 times 5x is 10x, and 2 times 4 is 8. Now, I just factor as normal, okay? The trinomial. So what two numbers multiply out to 4 and add up to 5? 1 and 4. And of course, you can do it on your graphing calculator. You would look for the y1 column would be in parentheses 4 divided by x, and y2 would be the same exact thing in parentheses, and then plus x. And you would look for where the last column says 5. You look at the previous columns, it'll say 1 and 4. And now you are done. Except for checking back, of course. X times x is x squared. X times 4 is 4x. 1 times x is 1x. So 4x and 1x add up to 5x. And then 1 times 4 is 4. And then distribute back. 2 times x squared is 2x squared. 2 times 5x is 10x. And 2 times 4 is 8. So you know you got it right. So when you can find a greatest common factor, it's shorter, quicker, and easier than when you cannot. Okay? You just pull out the greatest common factor and do the factoring. Now, I will tell you, the number one mistake that I see students do when they have a greatest common factor is they just kind of forget about that greatest common factor in the front, and in the answer space, they put x plus 1 times x plus 4. Don't fall victim to that. Remember, we started this lesson off today showing the kinds of mistakes that were made on the last test, and one of them was to find the area of the rectangle. And I'm convinced that the kids got the width with no problem, but then they forgot to go back and get the area. You cannot forget to include that 2 in the answer space. If I don't see the 2 and the x plus 1 and the x plus 4, the question is done wrong. So do not forget the 2 that's in the front. That's a very, very common mistake that's made. Okay? Let's have you try number 12, doing stop and start. Always look for that greatest common factor. If it's there, pull it out, then factor. Okay, so I factor out is the greatest common factor, or multiply the last by the leading coefficient. In this case, the greatest common factor is also a 2, so I pull it out and I get 2 times x squared minus 6x minus 40. Let's check ourselves. 2 times x squared is 2x squared, good. 2 times negative 6x is negative, I made a mistake. It should be negative 3x. See, that's why we always multiply back and do a quick correction. Okay, so this should be 3x, and this should be x minus 8 and x plus 5. So let's go to, but that shows you the importance of multiplying back. Multiplying back is a critical skill to have with this. Okay, so once again, we said that there's a greatest common factor of 2, so I pull it out, and I should have gotten, and I now have, x squared minus 3x minus 40. Then I factor that trinomial that remains. So I'm looking for two numbers that multiply out to negative 40 and add up to negative 3. Of course, you can do this on the graphing calculator too with y1 and y2. So factor that guy. So if I do factor it, the two numbers that multiply out to negative 40 and add up to negative 3 are negative 8 and 5. So let's distribute back and check ourselves. Okay. X times x is x squared. X times 5 is 5x. Negative 8 times x is negative 8x. So 5x and negative 8x add up to negative 3x. And then negative 8 times 5 is negative 40. Now I distribute the 2 back and I get 2x squared minus 6x minus 80. And I know that it's correct. Keep in mind, the number one mistake that kids make when they have a greatest common factor with a trinomial is they forget to include the 2 in the answer. Don't forget to include that too. Okay, so we've taught you two techniques here with the lead coefficients other than 1. The most recent technique, the one you should always try first because it's so much easier, is if they share a greatest common factor. If they do share it, you must pull out that greatest common factor. The other technique is going to give you a headache. And if there is no greatest common factor, that's when we multiply the last term by the leading coefficient, and then we factor that, and then we divide it back in again to balance it out. Take a look at number 13. What do you think it is? Do you think we pull out a greatest common factor, or do you think we multiply the last by the leading coefficient? Yeah, there is no greatest common factor. So we have to multiply the last one by the leading coefficient. Why don't you do that now? Do stop and start, and we'll go over the answer for you. Okay. So we already said there's no greatest common factor, so multiplying that 4 by the last term gives me x squared plus x minus 12. Factor that guy, I get x minus 3 times x plus 4. Quick mental check. X times x is x squared, x times 4 is 4x's, negative 3 times x is negative 3x's, negative 3 times positive 4 is negative 12. So far, so good. However, I got to remember that I have to balance that multiplication with division. This is the step that kids will forget with this technique as opposed to the greatest common factor technique. So I divide everything back in by that 4 that was the leading coefficient. If reducible, 4 over 4 is 1. If not, then I have to remember the elementary school trick of multiplying that 4 in front, and I get 4x minus 3 times x plus 1. Quick mental check to make sure that I did it correct. 4x times x is 4x squared. 4x times 1 is 4x. Negative 3 times x is negative 3x. 4x and negative 3x leaves me with a positive 1x, which is what I wanted. I also wanted the 4x squared. And negative 3 times 1 is negative 3. So ding, 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 I got it right. So what do we do today? What we did is 4 types of factoring. We did a basic greatest common factor factoring. We did a basic trinomial factoring. We did a not so basic factoring a trinomial with a lead coefficient other than 1, and we did it 2 ways. One way that we did it was by finding the greatest common factor, and one way was by multiplying the last term by the leading coefficient and then come back in and divide it back in later. So here's one example of each. Do some stop and start. I will go over those correct answers with you in just a minute. Okay, so for the first one, I look for a greatest common factor. They share a 5 in common. So it's going to be 5 times h plus 9k. Let's distribute back. 5 times h is 5h. 5 times 9k is 45k. So far, so good. Now, let's do the next one. You can do it either on the graphing calculator or using AM. Let's check the answer first. Then I'll go over how to have done it on the calculator. X times x is x squared. X times negative 3 is negative 3x's. 10 times x is 10x. So negative 3x and 10x add up to 7x. 10 times negative 3 is negative 30. So that is correct. If you did this on the calculator, well, first, if you did it using AM, you'd say what two numbers multiply out to negative 30? That's the M part. And A add up to 7. And the two numbers are positive 10 and negative 3. If you did it on a calculator, under Y1, you'd put in parentheses negative 30 divided by X. And under Y2, you would put that same exact thing plus X. Y2 is always the same. Whatever's in the first one, plus X at the end. Okay? And then you look at the two previous columns, it will tell you 10 and negative 3. So then I look at number 3. And I notice that they do indeed share a greatest common factor. It is 3. So the first thing I do is I pull out that 3 that they share in common. And that leaves me with x squared plus x minus 12. And then I need to factor that x squared plus x minus 12 using AM or the graphing calculator. I need two numbers that multiply out to negative 12 and add up to 1. Those two numbers are 4 and negative 3. Quick mental check. X times x is x squared. X times negative 3 is negative 3x's. 4 times x is 4x's. 4x's and negative 3x's add up to 1x. And 4 times negative 3 is negative 12. Okay. Then if I distribute that back, 3 times x squared is 3x squared. 3 times x is 3x. And 3 times negative 12 is negative 36. So, ding, 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 I know I got it right. That quick mental check is a great way to practice your algebra. It's a great way to practice your signs, positives and negatives, and it's also a great way to make sure that you're not making a mistake. So there's a lot of benefits to the quick mental check. Number 4, this time I look for a greatest common factor and there is none. So that means I have to go to the technique where I take the last term and I multiply it by the leading coefficient. So I take the 2, multiply it by the 5, and I get 10. Then I just factor that, which works out to be x plus 10 times x plus 1. I think it's pretty evident that two numbers that multiply out to 10 and add up to 11 positives are positive 1 and positive 10. But, and here's the part you can't forget, since I multiplied by the 2 and changed the question, I have to compensate for that and divide that last term back in by 2, which I do. 10 over 2 reduces to 5, and I'm going to take that 2 and put it in front of the x, because I can't leave a fraction there, and I get 2x plus 1. So x plus 5 times 2x plus 1, I think, is the correct answer. Let's do the quick mental check. X times x is 2x squared. X times 1 is x. 5 times 2x is 10x. 1x and 10x do add up to 11x's, and 5 times 1 is 5. So I checked it. I got it all right. So these are the skills we worked on today. Some pretty serious and challenging stuff. I hope you got it, but we're going to do one more day of it just to make sure that we really got the idea cemented in your mind. Okay? Have a great day.